Did you know that there are more galaxies in the universe than there are stars in our Milky Way? That's right. Astronomers estimate that there are around 2 trillion galaxies out there, each with billions of stars and possibility of a planetary system just like ours around each of them. But do you know the fascinating stories of people who discovered that some of these beacons of light in our skies were galaxies far, far away from our own? Let's find out. Born in the year 1730 in France, Charles Messier was fascinated by astronomy since early childhood. His passion and hard work took him to the court of King Louis XV of France. Now, as you know, back in the day, people were superstitious and feared unusual astronomical events such as eclipses. They believed that someday an object from the heavens can hit their kingdom. In order to relieve his people from the fear of the unknown, the king asked Messier to prepare a list of all the possible comets which can collide with Earth and cause destruction. In an attempt to do so, Messier realized that there were many fuzzy looking things in the sky which looked like comets but didn't seem to move much. This annoyed him very much, and in his frustration, he decided to prepare a list of all such fuzzy clouds to help him and other comet hunters in their endeavors. His final list is what we now call the Messier catalogue, the first ever documented list of astronomical objects, which, amongst others, included galaxies, even though its creator was clueless of his achievements. The Messier catalogue contains 110 objects, with each object name beginning with the letter M followed by a serial number. These objects are known by their Messier name to date. The Messier catalogue is particularly admired by amateur astronomers because not only is his list a good mix of galactic and extragalactic objects, but most of them are also easily observable with a good pair of binoculars or a small telescope. What Messier thought all looked like nebulae through his small telescope are actually a collection of objects from single stars such as planetary nebulae and supernovae, a collection of tens of thousands of stars in a star cluster to millions of stars in galaxies. But to him, all of these objects looked similar because the apparent size and brightness of bigger objects as observed by him were similar. In other words, if a galaxy is, say, 10 times as big and luminous as a star cluster but also 10 times farther away, then through a small telescope they will both appear faint hazy clouds of light. Little did Messier knew that he had created history by documenting observations of not just one, two, or three, but several nebulae much farther away than our own Milky Way. Nebulae that we now call galaxies. The King of France nicknamed Charles Messier the ferret of comets for his exemplary work in the field. It is an irony, though, that although his hard work was targeted at creating a perfect list of comets, today we remember Charles Messier for what he thought were anomalies in his research. We now have a lunar crater and the asteroid Messier 7359 named to honor his contributions to the field of astronomy. But the story doesn't end here. At around the same time, in Great Britain, William Herschel was trying to build a large telescope to satisfy his desire of understanding the universe. But unlike Messier, Herschel started his career as a musician. He was the son of a talented musician and a very talented one himself. In the year 1757, at the age of 19, he fled Germany due to the ongoing war and came to Great Britain in search of a better life and opportunities. William's talent as a musician got him recognition, and 13 years later he landed an exclusive position in the church choir at the Octagonal Chapel in Bath. Once he had established himself and his sister Caroline in Bath, his childhood interest in astronomy was rekindled, which led him to learn to build telescopes. The first telescope he produced had focal length of 7 to 10 feet. In the 18th century, the focal length of the telescope was the prime defining factor for its credibility. That is because most astronomers of the time were primarily concerned with improving the accuracy of positions of stars and the movement of the planets across the sky. Their endeavors were practical in nature with an intention to improve navigation, particularly for sailors on the high seas. Accurate positions of the stars were key to determination of latitude by sailors. Improvement in the timing of the movements of stars and planets allowed them to determine the precise time and hence their longitude on the planet. But improved position required a telescope with larger focal length because, as you notice here, focal length is inversely proportional to the angular size of the image. So, a smaller, well-focused image meant an accurate determination of positions of the object, which was possible by using a telescope of larger focal length. But to image fainter object, a telescope of smaller focal length is used. That is because the larger focal length produces larger images, which causes the light to spread over a larger area and therefore dims the image itself. No wonders then that Captain Jack Sparrow and his subordinates use a telescope with larger focal lengths. But nowadays we aim to build telescopes with larger diameter, that is large light collecting area, to serve the same purpose. Anyways, coming back to our story. His passion and experiments ultimately led William Herschel to build his most famous and productive observing facility, the 20-foot telescope in the backyard of his home in Bath. In the year 1781, he discovered the seventh planet Uranus with this telescope. This made him very famous and he was appointed the court astronomer by King George III. He was also made a fellow of the Royal Society. William made significant contributions with his telescope. He confirmed that many of the objects in the Messier catalogue were actually clusters of stars. Amongst others, Herschel pioneered the use of astronomical spectrophotometry using prisms and temperature measuring equipments to measure the wavelength distribution of stellar spectra, and in the course of these investigations discovered infrared radiation. He also discovered two moons each of Uranus and Saturn. But unlike his contemporaries, Herschel's motives were less practical. He wanted to understand the structure of the universe. With his sister Caroline's help, he mapped hundreds of nebulae. Today, we know Herschel's nebulae to be a collection of galaxies, star clusters, primordial gas clouds, and other astronomical phenomena. He confirmed that many of the objects in Messier's list were actually clusters of stars, and that was possible because from Great Britain and France, Herschel and Messier saw roughly the same part of the sky. But Herschel craved for more, and his cravings made him build the world's largest telescope of the times, his 40-foot telescope. It is fascinating that with a primary mirror made up of polished metal weighing over a ton, this magnificent structure took over 5 years to build and costed thousands of pounds granted by the royals of the times. This 40-foot telescope was a masterpiece which had emerged from the genius of William Herschel and had tested the limits of technology available at the time. In her memoirs, William's sister Caroline sorrowfully notes how the construction of this telescope consumed her brother and their entire home would be littered with metal sheets and equipment used by him. It is an irony, though, that because of its weight, which required several assistants working in harmony to operate it, and the impact of natural elements on the components, the giant telescope required a lot of maintenance and consequently hardly contributed to any significant discoveries, except motivating many others to pursue the functioning of the cosmos. Caroline Herschel was an accomplished astronomer herself. In her illustrious career, she discovered 8 comets, one of which is named after her. Caroline also catalogued more than 500 previously unrecorded stars and was the first woman to be paid for her scientific work. She received a handsome sum of £50 per annum by the Royal Astronomical Society for her research in astronomy as an assistant to her brother William Herschel. She was the first woman to be awarded the Gold Medal of the Great Britain's Royal Astronomical Society in the year 1838. It is noteworthy, though, that both of Herschel's telescopes, the 20-foot and the 40-foot, were reflecting telescopes with polished metal acting as mirror. A reflecting telescope uses mirrors as its objective, as shown here. On the other hand, the telescope which uses a lens instead of the mirror are called refractors. The largest refractor ever built and used for astronomy is the 40-inch diameter Yerkes Observatory Telescope established by the University of Chicago in the year 1897. It has a focal length of 19 meters in order to reduce spherical and chromatic aberrations. A refractor requires a large focal length, making the telescope bulky and more complicated to operate. It is due to these difficulties that refractors are almost out of fashion now, at least for large observing facilities. Herschel was made a Knight of the Royal Gulfic Order in 1816 and later the first president of the Royal Astronomical Society when it was founded in 1820, just 2 years before his death. His legacy was carried forward by his only son, Sir John Herschel. Amongst others, today William Herschel is remembered by his namesake 4.2-meter telescope on the Spanish island of La Palma. Sir John Herschel continued his father's observations of nebulae and double stars. John was a mathematician, astronomer, chemist, inventor, and experimental photographer who invented the blueprint. He also had great interests in botany. Amongst varied significant discoveries and inventions across many domains, Sir John made several great contributions to the field of astronomy. He was the first to notice the variability of the bright star Betelgeuse, the first to measure the solar constant, and the pioneer of stellar photometry. Sir John Herschel began the use of the Julian day system in astronomy. He named 7 moons of Saturn and 4 moons of Uranus, the 7th planet discovered by his father. He made many contributions to the science of photography and investigated color blindness and the chemical power of ultraviolet rays. But the one great thing he did was to take a journey to the southern hemisphere around the Cape of Good Hope. He, along with his wife and their 3 children, departed from Portsmouth in November 1833. On this voyage to South Africa, he made a catalogue of stars, nebulae, and other objects of the southern skies. In the year 1834, he began a survey of the southern sky from the Cape of Good Hope. This survey, the first systematic observation of the sky in the southern hemisphere, yielded more than 2,300 nebulae and more than 2,100 double stars, which he listed together with his father's discoveries in the General Catalogue of Nebulae and Clusters. This became the precursor to the new General Catalogue, later published by John Louis Dreyer and used to date by astronomers around the globe. The NGC name of any object is actually its serial ID in the new General Catalogue, which is a compilation of more than 7,800 astronomical objects, several of which are galaxies. But most of what we know about other galaxies are attributed to the genius of one man born at the turn of the 20th century, Edwin Powell Hubble. Hubble's passion to explore the universe led to discoveries which transformed the way we think about the universe and laid the foundations of the subject of cosmology. Hubble obtained his PhD from the University of Chicago in the year 1914. In 1919, his destiny took him to the Mount Wilson Observatory in California, which housed the 100-inch telescope, the largest in the world at that time. Edwin Hubble was interested in studying the faint patchy clouds broadly known as nebulae and brought them to focus using the monstrous machine at his disposal. Up until the 20th century, our universe was contained within the realms of the Milky Way, although some astronomers speculated the existence of other galaxies beyond it. Hubble's observations brought the proof required to confirm their theories. In 1923, he finally resolved stars in the Andromeda Nebulae and confirmed that it was a galaxy in its own right. Hubble's observations of Andromeda led to the discovery of the Cepheid variables. These are stars whose brightness varies in an orderly manner and therefore they can be used to measure distances in the universe, as we discussed in a previous video, the link to which is provided in the description below. Hubble continued to master his technique and went on to study many other galaxies, evidently confirming the speculations of his predecessors that there are millions of them in the universe. While many great astronomers of his time assumed the universe to be static, Hubble's genius proved them wrong by showing the universe is in fact expanding, a topic that we have already elaborated upon in detail in an earlier video. Almost 4 decades later, his namesake instrument was placed in the orbit to further our exploration of the cosmos, which is much bigger than our wildest imagination. And more recently, its successor, the James Webb Space Telescope, is once again changing our view of the universe with discoveries that are challenging our current understanding of the cosmos. More about them coming up soon. But now, I want to hear from you. What do you think about these mind-blowing discoveries and these stories? Drop your thoughts in the comments below, and if you enjoyed this exploration of galaxies, do check out our other videos. I'll see you next week. Until then, take care.